This is UC3 Rate question 5. So the figure below shows two taps, taps A and B, in an empty tap that measures 48 by 20 cm by 25 centimeters. Water flows in to the tank via tap A at a rate of 2.4 liters per minute. Okay, so we'll annotate the diagram as we read through. Water flowed out from the tank from tap B at a rate of 1.6 liters per minute. Okay, and we said that tap A was turned on at 6 p.m. 2 minutes later, tap B was turned on at 6:02 p.m. Part A helps to help us break down what is the difference in the volume of water flowing in and out of the tank per minute. So we notice that flowing into the tank is 2.4 liters per minute. So in every 1 minute, we have 2.4 liters flowing in, but we also have at the same time 1.6 liters flowing out. So if we take the difference between 2.4 liters and 1.6 liters, we will see that there will be net 0.8 liters flowing in, 0.8 liters flowing into the tank, and 0.8 liters is equals to 800 milliliters. So that will be the volume. The difference is 800 milliliters in a minute. For part B, what time will the tank be completely filled with water? So then we must break this entire scenario into two parts. First part is when it's 6 p.m. until 6:02 p.m. where tap A was turned on. So there was only tap A. Then until the time, which is the question mark in this question, we have tap A and B both switched on. And at this second bit here, the second part of the question, from part A, we know that the difference in the volume of water flowing in and out will be 800 milliliters from part A. And we can see that we'll use back liters, 0.8 liters per minute into the tank. Meaning to say, net, every minute there will be 0.8 liters of water flowing into the tank, and there will be more and more volume in the tank as the minutes go by. Then we must first figure out what is this volume that we get from the first 2 minutes. So since tap A, over here we see that every minute you have 2.4 liters. So we have 2 minutes. 2 minutes, we have 2.4 liters times 2. That is 4.8 liters. The whole capacity of the tank we also need to know, so that we know when will it be full. So the capacity of the tank will be 48 times 20 times 25. 48 times 20 times 25, and we get 24,000. That is 24,000 cubic centimeters. So 24,000 cubic centimeters is also equivalent to 24 liters. Okay, so you must get the conversion right. Then in the first 2 minutes, 4.8 liters has been filled. So we are interested to know 24 liters minus the 4.8 liters, which was filled in the first 2 minutes. What is the remaining volume to fill the tank, which is 19.2 liters. Then we also know that for every minute, 0.8 liters will fill in the tank from the second part. We will take 19.2 liters divided by 0.8 liters, and we want to know how many minutes that takes up. So we divide it by 0.8 and we get 24. This is actually the rate, and the unit for this is actually in minutes. That means it takes us 24 minutes to fill with 0.8 liters per minute into the tank. And that should start from 6:02 p.m. So to find the final time, the time at which the tank is completely filled with water, we actually need to take 6:02 p.m. plus 24 minutes, and we actually get 6:26 p.m. So that is the answer. This is the time when the tank will be completely filled with water.